Hi there, I'm back here teaching you about solving linear systems by substitution. The other day you learned how to solve a linear system of equations by graphing. Today our method will be substitution. This is lesson 6.2a. The other day when you took a look at systems of equations, you learned that there are three different types of systems. One system will have one single solution where both of the lines intersect at one point. Sometimes you'll have parallel lines where there's no solution at all because the lines never intersect. And then sometimes your lines will be on top of each other. They'll be coinciding where every single point meets and is a solution. So it's infinite solutions. Today our focus in lesson 6.2a is going to be just on equations that have one solution. So a system of linear equations that just has one solution where the lines intersect at one point. Okay? And in order to solve, we're going to be using the method of substitution. So notice here how both of the equations that I have are written in different forms. Back when we graphed to solve our solution, both of the equations were written y equals mx plus b. Well, when both of them are written in a different form, it may not be practical to graph. So we can use something called substitution. And really the substitution method is all about substituting or replacing. You're constantly substituting. In class today we watched a video that describes how to do this. If you're interested and you were absent, you can always ask me for that and I can share it with you. So I want you to look at the two equations and determine which equation is solved for either x or y. So where the x or y is already isolated. And you can see in the first one, this one says y is equal to 5x. So y is 5x. So I'm going to put a box around this expression. Like in the video, they called it a package. Because y is the same as 5x, I can go to the other equation and replace this y with a 5x. Okay, so I'm just going to replace this y with 5x and rewrite it. So instead of y, I'm going to call it 5x. Because remember, y is 5x. Now, I have one equation with one variable. X plus 5x is 6x. And I'm just going to solve for x. And I get x is 2. Oh, I have the coordinate of 2. So in my solution here, the x coordinate is 2. I'm going to put that in there right away so that I don't forget. Now, I'm going to substitute again. I'm going to use a different color so you can see what I'm doing. Now, knowing that x equals 2, I can replace the x in either equation with the number 2 and solve for y. It's always going to be easiest to replace into the package. And then you can do it in your head in most cases. If x is equal to 2, let's go back into the package, and in place of the x, let's make it a 2. Now, y is equal to 5 times 2. Well, 5 times 2 is 10, so y is equal to 10. See how I can do that in my head? So over here, y is 10. Now, these two linear equations, if they were graphed on a coordinate plane, they would cross at the one point 210. 210 is the solution to the system. It's the one point that both equations have in common. I could also check it. I could plug in a 2 for x into this equation and a 10 for y into this equation and do it in this equation as well, and both will check out. Let's take a look at example 2. All right, here's number 2. Now, in this example, I wanted to show you how you can use the method of substitution even if both equations are written y equals mx plus b. Now, you could graph it, but again, graphing isn't always practical. The numbers don't always work out nicely. So let me show you how substitution can be used. Both of these equations are solved for y. So I could have either package. Y is equal to 2x plus 7 could be my package. Or y is equal to x minus 1 could be my package. For this one, let's just do the top one. So y is the same as 2x plus 7. So I'm going to take this entire package, this entire expression, and replace it in the other equation for y. So instead of writing y, I'm going to put 2x plus 7 because y is 2x plus 7. Just copy the rest of the equation down, and now we'll solve for x. We have an x on both sides. Bigger party, I'm going to subtract the x from this side. Solving for x, take away 7. -1 minus 7 more, -8. So now I have that x is equal to -8. I have an x coordinate. So the point at which these two linear equations would cross on the coordinate plane, the point has an x coordinate of -8. So now we just have to figure out what's the y coordinate. So I'm going to take x equals -8 and I'm going to plug it into the equation that has the package. Remember, that's going to be the easiest equation to use. So if x equals -8, I'm going to go right into this equation, and in place of the x, I'm going to make it a -8. Now, what's y? Y is equal to 2 times -8 plus 7. Now, if you can do that in your head, great. Y is equal to 2 times -8 plus 7. And so I have -16, and I'm adding 7. Great. -9. And there you have it. Y is equal to -9. Now, if I were to graph both of these equations on the coordinate plane, they're going to intersect at the point -8, -9. That's my solution. Let's try number 3. All right, number 3 looks a little bit different, because in number 3, we see that the x is isolated. This equation says x is equal to -2y. Oh, but you notice here, the y is also isolated. I also see here that it says y is equal to 4x plus 3. So I could box up this package and put it up here, or I could take the x equals -2y and box up this package and put it here. You have a choice. Well, maybe for this one, I will use the top equation. So x is equal to, or x is the same as -2y. So if x is -2y, I'm going to take this -2y and replace it right here into the other equation for x. Let's rewrite this. Y equals 4, big parentheses. Instead of writing x, we're going to replace it or substitute it with -2y. Remember, x equals -2y, so I can take the x and change it to a -2y. Okay, let's simplify. Oh, I have a y on both sides. This is a 1 and this is a -8. This one's bigger. So let's go to the bigger party. Let's get rid of this one. Bring down your 3. Now it looks like we're going to have to divide by 9 to get the y. Divide this side by 9. 3/9 is 1/3. So y equals 1/3. Okay, I have one of my coordinates. Remember, this is the y though, so I'm going to put that right here in the y space. Now I'm going to have to go back up into my equation and replace y with 1/3. I have to find x. Well, like I said before, it's always easier to go back up into your package. So we're going to replace this y with a 1/3. Let me rewrite this so you can see it a little bit better. Here it says x equals -2 times 1/3. See how easy it is to solve for x? X is equal to whatever these two multiplied together are. Remember, change this into a fraction, and nothing to simplify, so multiply straight across. -2 in the numerator, and 3 in the denominator. X is equal to -2/3. Ooh, kind of a crazy one there. That one would be very hard to graph, wouldn't it? And that is the solution of the linear system. They cross at that point. All right, let's take a look at number 4. So take a look at both equations and determine which one of the equations is already solved for the x or the y. So which one says x equals or y equals? where we could box up an expression or package. Do you see it in the second one? This one says x equals this expression right here. So if x is equal to 2y plus 1, then I should be able to take the 2y plus 1 and substitute it right in here for x. So what I'm going to do is rewrite this top equation. But in place of x, I'm going to put big parentheses because that's where I'm going to be taking this expression and plugging it in right there. Big parentheses. And then just copy the rest down. Okay, so do you remember the package here? 2y plus 1? Since x is 2y plus 1, I'm going to substitute it right in here for x. So right here for x, I'm going to put 2y plus 1. There's my package. Now, my equation only has the variable y in it, so I can solve for y. First distribute, then bring down. Now, let's combine like terms. 14y, take away 2y. Plus 7. Okay, we want to get y by itself, so we'll minus the 7. 1 minus 7 is negative 6. Divide by 12. Negative 6/12 is the same as negative 1/2. So our y-coordinate is negative 1/2. So I'm going to put that right up here right away so I don't forget that that's my y. Now what I have to do is take the fact that y equals negative 1/2 and now substitute it again back up into either equation. I would say that the easiest equation would be the one with the package. So if y is negative 1/2, I'm going to go right in here to the package and make the y a negative 1/2. Now do you see how easy it's going to be to solve for x? X is equal to this right here. Half of 2 is 1, and it'll be negative. Oh, looks like x is equal to 0. Boom, right there, and I'm done. That's the point at which the two equations will cross or intersect on the coordinate plane. That's the one solution to the system. Let's try number 5. All right, here's 5. See if you can box the package. How'd you do? All right. This linear equation says y equals negative 4x minus 5. So since y is equal to negative 4x minus 5, I should be able to take the negative 4x minus 5 and replace it into the other equation for y, because y is negative 4x minus 5. I'm going to copy this equation, but where I see y, I'm going to put a big parentheses because I'm going to be replacing it with this expression right there. Copy it down. Now, instead of y, I substitute negative 4x minus 5. There it is. Okay, now I have one variable in my equation, x. Let's solve. But do you notice here? We have a negative. Remember, this is like a negative 1. We have to distribute this negative. Negative times negative is a positive 4x, and negative times negative 5 is a positive 5. Now we'll bring this down. We have more simplifying over here. Combine like terms. Keep the 6. Let's send home the 5. Negative 1 minus 5 more, negative 6. Divide, and you have the x-coordinate. Oh, lots of work, right? Okay, so x-coordinate's negative 1. Plug that right into your solution. All right, another substitution. Don't you love the substitution method? You're substituting and then substituting again. So x is equal to negative 1. Now let's go back into the equations up here and solve for y. So I'm going to take the x equals negative 1 and I'm going to plug it right in here into the package. Okay, I'm going to make this x a negative 1. So now, what's y? Y is equal to negative 4 times negative 1 minus 5. Now, you might be able to do that in your head. If not, you could rewrite it. Oh, y is equal to -1. Did you get it in your head? Did you were able to do it in your head? All right, there's our solution. Last one, number 6. Take a look at the equations. Which one has the package? Do you see the second one? It's solve for y. Y equals, and there we have it. So if y is equal to -3x plus 8, I should be able to take -3x plus 8 and substitute it into the other equation in place of y. All right, let's do it. I'm going to copy down the top equation. But the y here, I'm going to put big parentheses. Okay, so here's my package, -3x plus 8. It says y is equal to this, so I'm going to plug it in for y right here in the other equation. There we go. Now I have one variable to solve for. Ooh, looks like we're going to have to distribute. Be careful though. This 2 that you'll be distributing, it's a -2. Do you see the negative in front? So don't forget the negative. -2 is being distributed. -2 times -3, positive 6x. -2 times positive 8, -16. And then we can bring down the minus x in front. Okay, let's combine like terms. These two are like, -1 plus 6. Solving for x, keep the 5, let's add 16. And divide. Yay, x equals 4. All right, all that work and I got the x coordinates 4. The thing about substitution is you can't see what you're doing because there's no graph, so you can't actually see these two lines intersecting. It's just all algebra. Okay, so now that I have x equals 4, I'm going to go back up and plug that x equals 4 into the equation. Well, which one? It doesn't matter. It's just always going to be easiest to put it into the equation with the package. So y equals -3x plus 8. X is 4. I mean, you might be able to do this right here and then do it in your head. Y equals -3 times 4 plus 8. Yay, there we go. Perfect. And there's the point. That's the solution. They're going to intersect. Remember that I told you all of the examples that we were going to do today, that we were going to look at today, would all be points, would all be systems where both of the lines are intersecting. So every example we saw today, the lines would intersect and we got one solution. Now in lesson 6-2b, we'll take a look at these two types of systems, where what if we're solving with substitution and we get no solution, or what if we're using the substitution method and we get infinite solutions? That's going to look a little different. But for now, this is what we're focusing on. Thank you very much. Have a great day. Bye-bye.